Okay, number 1 asks you in section 4.4, what is meant by a marginal distribution? And I'm going to let you know, marginal distribution is a frequency, so we're looking at frequency, or we're looking at relative frequency, which we did in chapter, I think, 2, of either a row or a column. So it's either a row or column in a contingency table. The next part of the question is what is meant by a conditional distribution. A conditional distribution, these are terms that you need to know, is the relative frequency of each category of one variable. So it's a relative frequency of each category. Okay? And what we're going to talk about is that given the value of another variable in the table. So I'm going to show you how to do that. Number 2 says we're going to refer to table 8. Is constructing a conditional distribution by level of education different from constructing a conditional distribution by employment? So what we have is table 8, and we're asking if we're doing a conditional by employment versus education. So education versus employment. And if they're different, explain the differences. Well, they are different. In constructing a conditional distribution by education, we find the relative frequency within each column by dividing by that total for that column. To construct the conditional distribution by employment, which is a row, we find the relative frequency within each row by dividing by the total for that row. So let me go to table 8, and that way you can see what we're talking about. All right, this is table 8. Notice we talk about employed versus level of education. In a contingency, we would actually take this particular column and do this number divided by its total, this number divided by its total, this number divided by its total to get a relative frequency by education. If we're looking at doing this by employment, then what we're going to do is take this row and we're going to take this frequency divided by the total of this row, and then this frequency divided by the total of the row. So you will get different values. Let's look at this table 9. Notice we found the totals, so this is just doing a marginal distribution, is finding the totals of each one of these. Conditional means I'm going to take, if I'm looking at it by education, I'm going to take the 11,892 divided by the 27,541, and then I'll get a relative frequency by education. If I'm looking at doing this by employment, then I'm going to take the total here and do each one relative frequency. Now, this table here is a relative marginal distribution, and we're going to take the totals divided by the overall totals to get the marginal frequency. This is not a conditional frequency. This is the marginal. So notice we take the totals here divided by the overall total, and that will give you the relative frequency for did not finish high school. If you're looking at the relative frequency for being employed, you're going to take the total of this column divided by the overall total and get this relative frequency. All right, let's look at this one. Here we have a conditional frequency, and we're doing it by level of education. So remember I told you you'd take the 11,000 divided by the total of this column, and that is your frequency by level of education. Now this is looking at it only by level of education. If we are going to do it then by employment, then you're going to do the same thing going on the rows, and you will get different relative frequency values here. So yes, they're going to be different because you have a row versus a column. Now the next question asks, explain why we use the term association rather than correlation when describing the relation between two variables in this section. The term correlation is used with quantitative variables, okay? So that's when we have quantities related to them. In this section, we are considering the association between qualitative. So in number 3, there's the difference is quantity versus quality. Okay? So we're looking at association when we're talking about non-numeric values. All right, Simpson's paradox. It's a situation in which there's an association between two variables where it changes direction or it goes away when a third variable is introduced. So you might have an association that's with the two variables and all of a sudden you put in a third variable and then that association goes away. And we'll talk about some examples also. Here's our table of values. This is where if you have Excel, it works really nice to do this in Excel. Here's my table of values and I need to make a frequency marginal distribution. All that means is I'm going to total a bunch of things up. So when I total these across, I will get 80, and when I total these across, I will get 220. When I total these down, I get 100 and 100 and 100. This total and this total better equal the same thing, and it's 300. So that's how you do a frequency marginal distribution. To do relative frequencies, notice we have these totals up here. So to get this relative frequency, we're going to take 80 divided by 300, and you're going to take 220 divided by 300, and this total should end up being 1 here. On this one, you're going to take 100 divided by 300, 100 divided by 300, and 100 divided by 300. When you do that, you get 0.267 and 0.733. Here you're going to get, now be careful of rounding because it goes on forever, it's 0.3, 0.3 repeating, and 0.3 repeating. So if you add the repeatings without dropping it or rounding it, you'll get 1 as well. Now that's a relative frequency marginal distribution. Now what we're going to do is a conditional distribution by the X column. Now remember, this was a 35 and the total was 100. So what we are doing is we're going to take them by the total of each column, 0.35, 0.65, and this total better equal 1. And now we're going to take 25 divided by the total of this column, which is 0.25, and then 75 divided by this is 0.75, and then the total is 1. And the same thing over here, 20 divided by 100, 0.2, 80 divided by 100, 0.8, and your total again is 1. Now this is what you consider a conditional distribution by the X column. If we're going to do a conditional distribution by the Y column, then we would be doing the Y values divided by the total of that particular column. Okay, so here is the conditional distribution by the X's. So we have, remember up here, we have the relative frequencies. So we have to do it by Y. So we have this particular X1 has a 0.35 and a 0.65, 0.35 and a 0.65, 0.25 and a 0.75, 0.2 and a 0.8. And so this is how you would do it. Notice I titled them, labeled the columns, put a title here, and have a legend.